Good morning and welcome to webinar by BrankoGems. I hope you're all okay and you can hear me well. We have a very interesting topic today and very interesting young gemologist, retail gemologist, Randall Lightfoot from USA. And the topic is retail gemologist, why diamond science matters now more than ever. Very important topic. And I'm glad many of you sign up. Many of you are wholesale or retailer, and of course, many gemologists and appraisers as well. I'll introduce Randy a little bit later. I'll just tell you a few more things about what I'm doing the last 4 years, not only by myself, with my colleagues around the world, including my colleague Dusan Simic. We are hosting a lot of people from around the world doing different topics. And guess what? It's about diamonds most of the time, but not always. We also have other topics on gemstones. We will have more in 2023 to 2025. If you stay toward the end, you will hear more about that. It will be approximately 1 hour with me and Randy, and then we'll have questions and answers. And then you can basically work with us and talk to us, and we'll answer your questions. This is a company I'm doing a lot of education and consulting with Elena Deljanin, Gemological Research Industry Inc. You probably took some of my lectures or workshops or my colleagues and know that we are into education. We are really transferring our research data and information to lectures and practical webinars. You can see on the top, we are doing a lot of webinars, actually almost 40 webinars in 4 years now. And 1/3 is fee-based and 25 or more are free, actually, webinars to listen on great experts around the world. We do conferences, as you know, Mediterranean Gem and Jewelry Conference. It was 6th one in August. You can see more in a few minutes. And what is new, I'm starting to do international conferences. Next one will be in July 2023 in Brisbane, Australia, with the National Councillor Julie Valderes from Australia. And all these you can find on BrankoGems.com shop, all information, samples, webinars, and books, a lot of books from me and my colleagues. This is something to remind you for those who came to the conference, and thank you those who came. And I think you appreciate that we were brave and quite bold to do this conference in the middle of a pandemic, not middle, but at the end of pandemic and the war. But it was a great success. It was a smaller conference than usual, but we had a lot of good feedback. We did 4 workshops on gemstones and diamonds. We did a lot of trips in Greece, North Macedonia, and Serbia, visiting 3 countries and visiting mines. So those who wants to see more, you should go to the website. And it's just a reminder for those who are here with us. Some of you are on the great tours we have in Thessaloniki and great workshops we have on color diamonds, opals, colorless diamonds, and Laura Kiefert did great new workshop on origin of gemstones, country of origins. You can see our male speakers here. Elena is missing. And she was a part of this conference, of course, and we had a lot of events, post-conference dinners, gala dinners, tours to the Athos, which is the holy mountain, tours to the marble and occasionally rubies in North Macedonia in Prilep. We went to the mine in Rudnik in Serbia, and we visited wineries, and it was really a great experience. I encourage you to sign up for the next one. It will be in Italy, Slovenia, 2024. Anyway, now it's time to wrap up my introduction, introduce the topic, what is not only about laboratory grown diamonds. I think Randy will cover diamonds in general, of course, natural diamonds, and how he can use his techniques, standard instruments, to screen them and in many cases identify the origin. For those who listen my last webinar, what is June 2022, I was talking about my way to do it in CGL laboratory and why it's important to combine different instruments. Dusan and myself talking about this in last 15 years in our 3 editions of book Laboratory Grown Diamonds. You need to combine 2 or 3 instruments. You can see here example how it's easy to make mistakes if you're not experienced or not checking your diamond carefully. This is a diamond of 4 carat that had the green fluorescence and the long UV was stronger, short UV was weaker. But because ID100 of GA give a referral, a lot of people are relying on these machines and don't think what is it that means. It's mean that stone has to be checked more with another instrument. Doesn't mean it's synthetic, but that lab gemologists call it synthetic. And of course, with the photoluminescence, I could see that there's a nickel lines and hydrogen lines in infrared. It was definitely 100% natural diamond. So this is just introduction. Some of these techniques Randy will cover in detail, and I would like to introduce Randy. I met him actually a few years ago virtually. We never met in live. Hopefully we'll do it, Randy, in next year. He was reviewing my book on diamonds, and it was a great review. And there's some similarity between Randy and myself is that he's also a geologist, and he started his career as a gemologist at GIA, Gemological Institute of America, end of 20s like me. And the one biggest similarity, I think he has a big passion for diamonds and for education. And this is something very important. And I think without that, you cannot go into research. He's a retail gemologist at North Carolina now. Also learn how to use properly instruments, especially microscope, because Randy is a great photographer of inclusions and using cross-fluorescence filters. So Randy, floor is yours. Please ask questions during the talk, and at the end, I will repeat these questions, and Randy will be happy to answer. Thank you.
Wonderful. Thank you very much for that generous introduction, Branko, and definitely thank you to everyone who's attending. It's an absolute pleasure to be able to contribute to the ongoing practical webinars that you can find on BrankoGems.com. So again, thank you, Branko, for inviting me and making this possible. So the majority of you, of course, already aware of what I'll be speaking on today, and my subtitle is just slightly provocative: why diamond science matters in retail now more than ever. And I'll be discussing why this is through using standard methods of evaluation and my findings. So what we can expect in our journey together today, of course, we'll be going over some of the standard methods of evaluation. Specifically, I'll be focusing on cross-polarized filters, or CPF, which is the one method that I've grown very fond of. And then we'll be diving into some diamond science. So of course, some of the basics, and then what I would put forth and argue as kind of above average knowledge with regard to type classification, system, and defects in crystal chemistry. Then we'll finally get into some beautiful images using CPF and long wave UV. And because it is a kind of a hot button issue right now, and there seems to be a lot of confusion, diamond verification instruments, some of you will probably have heard these referred to as black boxes or diamond testers, diamond screeners. I'm going to be referring to them as DVIs just for short, just so everyone's on the same page with regard to that. And then wrapping it all up with why this even matters for retail jewelry professionals. And this has been an idea that I've been flirting with for a couple of years now, why professionals in retail, no matter your role, if you're a diamond buyer, appraiser, or if you're on the sales floor, why understanding and having a deeper understanding of diamond science matters. Some of you might be familiar with this friendly and jolly face, Dr. Richard Feynman, and he's been a very large influence in my independent research throughout the years, ever since I got into my undergraduate career in geology in 2013. He won the Nobel Prize in theoretical physics for quantum electrodynamics, rather. Of course, it has nothing to do with what I'll be talking with today, but I've always made it a tradition to include a quote from him. I learned very early on the difference between knowing the name of something and knowing something. And I'll explain why this bears very strong relevance to what we'll be talking with today. And I would say a good example of this is the majority of us will have heard the types of diamond But it seems as though that nobody really dives into them in the retail sphere of our industry. And so it's not enough just to know the name of something. We have to, of course, dive into it and understand it. Some clarifying points before we move on. My goal is to reinforce the importance of using standard methods of evaluation and, of course, motivate those working in the retail sphere of our industry to practice them. And this is just my way of saying that diamond science is not restricted to the lab. Now, of course, I'm overemphasizing this point, and I'll continue to overemphasize this, of course, because I'm biased, but given my inclination for a scientific attitude, but it's not restricted to the lab, and it's not as scary as what some people might think. It's always good to remind everyone that as industry professionals, we are all still responsible for achieving continued education, investing in equipment, and adhering to updated industry standards, no matter your level of expertise. Standard evaluation methods do not replace advanced testing techniques, and furthermore necessitate such testing to confirm or dismiss screening observations that you might otherwise use using standard methods of evaluation. While I'm not an academically trained research gemologist, I do consider myself one by hobby. I'm a retail gemologist-appraiser, as the majority of you know, using standard methods to observe diamond for clues to origin and possible treatment. And it's a good, just a clarifying point. When I say origin, I don't mean geographic origin. I simply mean origin with respect to natural versus lab grown. Some of my findings or images that I will be sharing with you today will be without fluorescence images. And I do apologize for this. The majority of the images I'll be showing is from my earlier work, which I did not use all the methods of the standard methods. And not all of the diamonds that I'll be sharing today will have been verified using optical spectroscopy, only supported by standard methods of evaluation. So I first came across these standard methods when I'd come across a book by Dusan Simic, Natural or Synthetic Diamond, identifying with cross-polarized filters, diffused light, and UV light. And it's a relatively small booklet, it's relatively thin, and it's an easy investment. And I encourage everyone at the end of this talk or even during to go ahead and find this. I believe you can find it also on Branko's website. I found it through the National Association of Jewelry Appraisers. And so starting out, we have diffused light. This is where we can identify internal graining and possible zoning, and of course, inclusions. With respect to internal graining, for those who might not know or grade diamonds or look at diamonds enough, when we're using these methods of evaluation, specifically for CPF and diffused light, it's important that we're viewing the diamond in pavilion view in what we call bright field position. So in other words, we have inclusions that appear dark against a bright background. And if you rock and tilt the stone slowly back and forth, you'll see these what we call kind of an optical characteristic that disappears and reappears. And it's what we refer to as internal graining, or it's basically just a distortion of the crystal lattice. And then we get into CPF, which effectively helps us to identify strain, otherwise known as the acronym ADR, or anomalous double refraction, which I'll be defining in the coming slides. And then I'll be coupling that with what we refer to as a first order red compensator. And I won't go into too much detail other than that it helps to exaggerate strain patterns to make them more apparent. And also it's just a very rewarding, colorful scheme in the diamond to be able to observe. Then we move on to UV light and fluorescence reactions to long wave and short wave. I won't be touching base too heavily on fluorescence. The majority of my talk, as I'll be mentioning momentarily, is going to more so heavily focus on CPF, but with fluorescence, you can get some very appealing and interesting and curious fluorescent reactions. It's important to note here, and Branko had mentioned this with the DVIs or diamond screening instruments, that you want to use at least two methods for the same reason that you don't just use just a refractometer when you're identifying gemstones. It's a bad habit and frankly kind of bad juju if you just use one method of evaluation. So you always want to exhaust as many methods as you can at your disposal, because the main point is to be able to defend your conclusions. And the best way to do that is, of course, again, to exhaust all the methods you have at your disposal. I'm going to reemphasize this point throughout my talk. Given the complexity of diamond chemistry, advanced testing is required to validate certain results obtained by standard methods. Now, I'm not saying that you must send all of your diamonds for advanced testing to major labs all the time. We all know that's just not financially feasible. But there are going to be certain instances that's going to necessitate it. But it's for this reason also that we have certain terms that we use with standard methods of evaluation, such as diagnostic or typical. And I'll be referring to these terms when we get into my findings, and it'll make a little bit more sense then. So as I'd mentioned, I'd focus mostly on CPF, and with CPF, it effectively converts your microscope into a polariscope capable of high magnification and photography. And so here I've borrowed an illustration from the second volume of the Photo Atlas of Inclusions in Gemstones by the esteemed Koivunen and Gublin. And this is just going to be a cross-section of the optical train that you could expect when you outfit your microscope for CPF. So starting from the light source at the bottom here, of course, then we have our sample, and between the samples, we have the polarizing plate. And then I've superimposed the first order red compensator. I just went onto Edmund Optics and just bought I think it's a 2-inch by 2-inch film, a first order red compensator, relatively easy and not that large of an investment at all. You just slip that between the first polarizing plate and the sample. And then of course you fix your analyzer, the other polarizing filter, just beneath the optics of the pod in your microscope. And for those who are interested, this is generally what my setup looks like, not just with CPF and when I'm evaluating diamonds, but just in general when I'm taking photomicrography. So for those who follow me and comment their thoughts on my photomicrographs on social media, thank you. But this is just kind of my general setup and how I go about it here. It is a little bit easier if you have a trinocular pod, but you can get away with using a binocular pod if you don't have the money to fork out for a trinocular one. And so through our journey today, we'll be going through a bunch of images that I've taken of various diamonds, both natural and lab grown, and those that have been treated using diffused lights, using UV, using CPF, and then of course using CPF coupled with a first order red compensator. And I will say, and I'll reemphasize this point a few times too, that it's not always necessary to use a first order red compensator. Sometimes you can see the strain pattern well enough without it, but nobody is going to really argue the natural aesthetics when you combine CPF and a first order red compensator. So we're going to reel back a moment before we actually dive into anything, and we're going to scratch the surface, pun intended, and just kind of go over some of the basics. When people think of diamond, they might typically think of the standard round brilliant cut somewhere on the D to Z. Of course, the majority of us, if not all of us, should know, of course, that naturally and artificially, diamonds can come in many different colors. And you might have even learned in your introductory diamond courses or your independent work, of course, the natural morphology. This photo here I've taken of a modified octahedron, and here we can see the trigons. And this is, again, just a very brief list of some of the things that you'll learn. And this is mostly going to be tailored from my understanding and perspective to identify diamond from other colorless stones that perhaps attempt to imitate it, not necessarily natural from lab grown. So then trending into lab grown diamonds is a photo I've borrowed from the Google. On the left, we have HPHT grown diamonds, high pressure, high temperature. And this is a photo I've taken of the diagnostic metallic flux inclusions that we can expect to see. These inclusions are going to be a mixture of the metallic catalysts that are required when growing these lab grown diamonds. And so if you have enough of these inclusions that perhaps are shallow enough to the table facet, you can actually attract a magnet, attract the diamond to the magnet. The second method by which we grow diamonds is chemical vapor deposition, or CVD. And here's another photo I've taken of a CVD diamond with a dense cluster of needle-like inclusions. And I say needle-like because this is the structures of the inclusions that we see in CVD don't quite parallel what we see in natural diamonds. And if you're not too familiar or have developed a keen eye for inclusion identification in lab-grown diamonds, this might confuse you or compel you to misidentify this diamond as a natural instead of a lab-grown. And so if you depend solely on high magnification, for example, and don't use any other standard method, you can be in some hot water. So from here, I'm not going to go too much more into lab-grown diamonds. So from this point, I'm simply just going to encourage all of you to invest in Branko and Dušan's book, Laboratory Grown Diamonds. In this book, you'll find a lot of very fundamental, very helpful fundamental information on both of these processes in detail. And of course, they go over some of the standard methods of evaluation. And for the true nerds who are attending, who are really into the advanced science, they go over optical spectroscopy as well. So here's where we're going to start to trend into what I would be considering above average knowledge here. Of course, in introductory diamond courses, you'll learn that diamond's made of carbon. So we have one carbon atom bonded to 4 neighboring carbon atoms held together by covalent bonds in a tetrahedral coordination. And so we see the tetrahedron here to the left in this illustration. You get enough of these tetrahedrons that attract and build on one another, and we get what we refer to as a unit cell, which in mineralogy is what we refer to as the basic building block for any mineral, and of course, gemstone. And we can go ahead and simplify this into a 2D diagram, where again, we have one carbon atom bonded to 4 other carbon atoms by 2 valence electrons. I won't bother to go into the chemistry. I don't want to scare too many people away too early anyway. But I will say here, and I want to make the point that when a diamond is composed strictly of carbon, this is where we have a perfect diamond, and it's perfectly colorless and transparent. Of course, the majority of the diamonds that we're familiar with are not like this. And this is because Mother Nature cooks in a very dirty kitchen. And it's because of this dirty kitchen that we have the type classification system of diamond, which can be defined simply as the relative presence and aggregation of nitrogen and boron impurities in the crystal lattice. I've borrowed this type classification system from the GIA and modified it ever so slightly. So we're going to be diving into this just a bit. The majority of the diamonds that we all love and know are going to be of type 1A, combination of the A aggregate and B aggregate. And here in this illustration, should be able to put it very plainly. In the A aggregate, we have 2 nitrogens that are paired together. In the B aggregate, we have 4 nitrogens that are surrounding a vacancy in the crystal lattice. And so this is going to constitute, I think it's an estimated at least 97% of natural diamonds that we come across are going to be of type 1A, AB. We can move on then to type 1B diamonds, where we have isolated nitrogen. This illustration is not to say that there are only 3 nitrogens in the crystal lattice, just that there's enough of a quantity of isolated nitrogen to what we call to produce an easily measurable nitrogen-related absorption in the defect-induced 1 phonon region using Fourier transform infrared spectroscopy. Aside from that being a mouthful, the only reason why I decided to put this in there is just because it's important to note that with type 1 diamonds, we have nitrogen in enough of a quantity in the crystal lattice to go ahead and be able to measure it. And this allows us, of course, to be able to classify which type it might be. We move on then to type 2A, where I've heard a couple of friends and colleagues throughout the years who claim to have been taught that type 2A is going to be as the simplified diagram in our previous slide, where it's pure carbon. And this is simply untrue. There's still nitrogen in the crystal lattice in type 2A diamonds, just that there's not enough at a part per million level to produce that nitrogen-related absorption in the defect-induced 1 phonon region. It's important to keep that in mind. And then we move on to the type 2B. Most of us are going to be familiar with this mostly by color. Of course, we have nice isolated boron now substituting carbon in the crystal lattice, and that's what produces that brilliant blue that we're familiar with. And so when we think about nitrogen and boron and perhaps other impurities in the crystal lattice, we can then move on to understanding the defects. These impurities synonymous with defects in the crystal lattice. Diamond gets its color by the defects it contains. And the type of defect will dictate how a diamond selectively absorbs parts of the electromagnetic spectrum, thereby resulting in various colors. And this is just going to be a refresher slide, another illustration I've borrowed from the GIA. And for this purposes, we won't be focusing on the spectra data. Of course, I do want to just call attention here to the left portion of this illustration. Not just diamond, of course, all gemstones selectively absorb parts of the visible spectrum, and then, of course, don't absorb parts of the visible spectrum. And it's part of this not absorbing part of that visible spectrum that we then perceive as the body color of the stone. And if you want to learn more about the listing of defects in diamonds specifically, and the types of defects that cause color and fluorescence, the first reference I have here from the G&G, it provides a really great chart. And then the illustration, of course, that I borrowed this from is from the second reference here from another G&G article. Some educational points before we really dive into it. Not all types of diamonds will be of natural or lab-grown origin. And so by this, I mean, when it comes to HPHT diamonds, as grown, they are either going to be type 1B or type 2A. With CVD diamonds, as grown, they're going to be type 2A. And when I say as grown, this is going to be without any kind of treatment. And as I'll be getting into later in my presentation, treatments can rearrange the defects in a crystal lattice, thereby changing its type. So when I say as grown, I mean that as they are grown, of course, from their process. Growth conditions vary significantly between natural and lab-grown diamonds, causing them to have their own unique defects. And this is important, again, to keep in mind, notably with optical spectroscopy. Any type of diamond can be treated to improve color by different processes. High pressure, high temperature, atmospheric pressure and high temperature, and irradiation, all at various pressures, temperature, and time variables, and all of that still depending on pre-existing defects and the as-grown diamond type. And so just to touch base on that a moment, there are a lot of variables that come into consideration. And this is one of the reasons why researching diamonds, not just using standard methods, but of course their advanced testing is so interesting and curious, because there are so many combinations within the variables of treating diamonds that it almost seems endless. Optical spectroscopy, again, just to reemphasize my point, is required to conclusively identify defects in diamond types, thereby determining origin and any treatments present. Standard evaluation methods can give clues to diamond origin. So again, natural or lab-grown, and any possible treatment. My main point with all of this is to maintain an air of skepticism. And so if there's anything that you're going to take away from this slide, it's my strong encouragement to tap into your inner scientist, have that air of skepticism, because although there are going to be diagnostic or typical strain patterns that I'll be showing you, that you can be 98% certain a diamond is this or that, you still want to maintain that air of skepticism, because again, anything is theoretically possible, again, with the numerous combinations of treatments out there. So we've talked about defects in diamonds dictating color and also just fluorescence reactions, but we haven't quite dove into what a defect is. And quite simply, a defect in diamond is anything other than pure carbon and without any distortion of the crystal lattice. And we can categorize defects into two categories. We have point defects, which would be your trace elements or impurities, if you will, nitrogen and boron that we've already touched base on, silicon, hydrogen, just to name a few, and vacancies. So these can be isolated, or these vacancies can be paired with a nitrogen. And these are defects that are going to require advanced testing to be able to identify. And of course, in identifying these point defects can also help us identify the type of diamond. And in the second category, we have extended defects. So this will constitute more geologic forces or stresses, mechanical stresses on the crystal lattice, plastic or elastic deformation of the crystal lattice, slip traces, dislocations, and vacancy clusters. And it's important to note here that these defects, the extended defects, can be large enough to see under high magnification. This isn't always the case. Mother Nature doesn't make things too easy on us, of course, especially when it comes to standard methods of evaluation, but it is important to note that you can see extended defects. And again, going back to internal graining, if we're just using diffused light, we can go ahead and see, if we rock and tilt the stone slowly, potentially see internal graining in natural diamonds. This all matters because point and extended defects can cause variations in the refractive index of diamond that we can then observe in the form of color when using CPF. And going forward, I'm going to refer to all of this as strain. These variances in refractive index, I would be referring to as strain. And so another way that we could put this is that this is also referred to as anomalous double refraction. And for those who aren't familiar with ADR, ADR is a doubly refractive effect seen in a singly refractive stone. Diamond is not the only one. If you have your GG, you will know, of course, that you shouldn't, for example, when you put synthetic spinel or garnets in the polariscope, you'll end up seeing very severe cross-hatching, and that's just due to the way that those crystals had grown. Synthetic spinel is actually a very great example. If you have one in your inventory, go ahead and look at it in the polariscope and you'll know exactly what I'm referring to. Defect distribution in natural diamond is very often highly heterogeneous. And this is actually a quote from Dr. Thomas Hainshuang in Branko's recent book that I'll be touching base on later in my presentation. And to illustrate this point, I'm taking a photo of just a standard round brilliant cut. I believe this was graded as G color. And it's of course mounted in a 3-prong martini stud. And diffuse light, we don't really see much of anything going on. You might be able to point out some inclusions here. What we're seeing here, shame on me, the diamond wasn't clean enough. And so on the pavilion, we see some dirt and smudge, but there are some very small to small size inclusions floating around in the table facet. When we subject this stone to long wave UV, we see something very interesting happen. Aside from the common blue fluorescence that natural diamonds can fluoresce as, not all natural diamonds fluoresce blue, some don't fluoresce at all. In this instance, of course, we do see the blue, but we also see something very peculiar going on when we subject the stone to UV. And so when we zoom in on that, we start noticing that perhaps this is a cloud. And in fact, if you were to zoom in just using diffused light, you will have seen a small cloud that has a very low relief relative to the background of the diamond, which is why we can't really see it using diffused light. But again, using UV, we see this. And I wanted to illustrate this point because I think this is a very great way, again, just to illustrate that defect distribution in natural diamond is very highly heterogeneous. It can be gradual or it can be as stark as something like this. Touching base then on artificial introduction of defects, or what we can coin as treatments, can effectively remove, displace, or rearrange the defects in the crystal lattice. And to illustrate this point, I've borrowed an illustration from a webinar lecture that Branko hosted with Dr. Alan Collins in May of earlier this year. When bombarded with radiation, molecules in the lattice begin to jiggle, which creates energy in the form of absorption and luminescence. And this is just very simply stated. And this is why I wanted to use this illustration, because when we induce enough radiation, it could be enough to bump a carbon atom out from its original position in the crystal lattice, thereby creating a vacancy and pushing that carbon atom into what we refer to as an interstitial position. And in doing so, we can drastically change the potential color or fluorescence reaction and CPF strain patterns as well. This energy then can be measured as a kind of fingerprint unique to certain impurities and other defect types. So when we move on to CPF specifically, to get into some real fun, this is another booklet by Dusan Simic, identifying diamond types and synthetic diamonds with CPF. So we've talked about diamond defects, what they are, and how they can dictate color. But we need to understand some of the more common or typical things to look out for when we're using CPF. In natural diamonds, simply we can see a smudgy, uneven, or random appearance. The strain can also follow the octahedral plane. And in my findings, I've also often seen these strain patterns following internal graining, which is a peculiar point to make that I'll be making later on in my presentation. You can see tatami or crosshatch pattern, possibly resultant from HPHT treatment, modified strain caused by enhancement or treatment. And this is where things can get a little bit tricky with natural diamonds, because these strain patterns could resemble what is observed in CVD grown diamonds, which I'll be touching base on momentarily. Depending on the severity of strain, we can see what we call low order interference colors or high order interference colors. Low order interference colors are going to constitute your blues, grays, and browns, while your higher order interference colors are going to be pretty much every other color of the rainbow. And for this, you won't need a first order red compensator. And I know I haven't shown any images quite yet of what this looks like, so I'll be sure to bring this together and round back to this in my findings. When it comes to lab grown diamonds then, HPHT grown diamonds are categorized as having an extraordinary lack of ADR or strain. It's important to note, though, that it's not that HPHT grown diamonds don't have strain. They certainly do. It's just that it's weaker and that they have an extraordinary lack of it. So do yourself not to be convinced that if you don't see a strain, it's not that the diamond is devoid of it completely, just that you might have to rotate your stone a little bit more slowly and pay keen attention. With CVD grown diamonds, this is where things can get a little hairy. We can see the parallel or columnar growth patterns, tatami or crosshatch patterns resultant from post-growth treatments to improve color, and then seemingly irregular patterns. So we can either see transverse to the growth direction. When I mean transverse, I mean if we have just parallel lines here and then perpendicular, transverse is going to be at any other angle that's not going to be perpendicular or parallel. And I have an example of this to illustrate that point. More importantly, though, another major point in my findings that I'll dive into later is low order interference colors that seem to repeat themselves evenly throughout a CVD grown diamond, unlike natural grown, just natural diamonds with high strain of a similar repeating pattern. Again, haven't shown any images yet to illustrate this point, so don't be worried if this doesn't quite make sense yet. I'll be sure to tie back to it. So again, the strain pattern suggests clues. And it's important to note too that strain theoretically cannot be removed or induced, only altered by treatment. And I say theoretically again, because to my current understanding and findings in literature and research available, I have not come across literature that suggests otherwise. So if anybody attending has, please make me aware of this in the Q&A after my talk. So then when we actually present images, this is going to be all of natural diamonds just using CPF, the smudgy, uneven distribution, possibly caused by point defects. And this is going to be low order strain. So in this image, again, in the pavilion view, we want to make sure we're in a bright field, because if we're in a dark field, we won't really see much of anything. And the proportions are going to be slightly different from diamond to diamond too. So you want to just do your best to achieve bright field positioning. So this is again, possibly an uneven distribution of point defect centers. In my next example here that I've taken, a low order strain again, possibly caused by a combination of extended defects and point defects. And this time they're quite clearly outlining the octahedral plane. And when you see stuff like this, is actually pretty exciting. And this is what I was referring to earlier as very rewarding natural aesthetics. We can also see elastic deformation of the crystal lattice around the crystal inclusion. Here we still see low order strain. And I do just want to point out that relative to the rest of the image, we can see localized around the stress fracture in this crystal inclusion strain. This could have been resultant either during or after growth, or possibly even during the preforming and polishing process. Who knows? But either way, the point here is that we do see the strain localized. And so we can feel confident that this is just elastic deformation around the crystal lattice. A great example of high order strain throughout the stone, suggesting severe plastic deformation. This is going to be different. So the difference in elastic and plastic deformation is that with plastic deformation, this is going to be resultant more so from geologic forces, again, either during or after growth. And here is a great example, again, to just try to tie it in. We don't need a first order red compensator to go ahead and see the higher order interference colors. This diamond already comes with high enough strain. So with this high strain comes with greater variances in refractive index. And the greater the variance in refractive index, the broader, the more colors you're going to see when using CPF. Touching base then on CPF examples of the tatami and crosshatch pattern, here we have a treated natural type 1A diamond. And when we see that your regular patchy pattern with needle-like discoloration, there's only an indication that this diamond may have started out as an unattractive yellow or brown color, somewhere perhaps lower on the D to Z. FTIR spectroscopy is required to determine the form and aggregation of nitrogen in this diamond. And when we juxtapose this with another diamond, here we go, treated CVD grown diamond. This is as stated by a lab that I'll remain anonymous, but we can see that the crosshatch or the tatami pattern is quite different looking than what it is in the previous example. And here I've superimposed lines. If you didn't notice already, aside from the uneven distribution strain pattern, that you can see the internal graining, and that if we were to view this natural diamond under diffused light, we would see, as we slowly rock and tilt the stone, the internal graining. But what we see here in this diamond, again, as stated by the lab, is a treated CVD grown diamond, broader banding or broader bands that intersect one another. However, this is where we have to maintain that area of skepticism, because this could also be an HPH treated natural type 2A or 2D diamond. So again, just going back to using multiple methods of evaluation, if you were just to use CPF, you could easily confuse yourself and misidentify the stone. And in that instance, if you're an appraiser, for example, there could be the difference in thousands of dollars. So now we jump into some findings of mine that I hope will certainly motivate you if I haven't already done so. With HPHT grown, round brilliant cut, light blue, we see in diffused light, really nothing regarding internal graining or zoning or anything like that, but we do observe the metallic flux inclusions. And of course, again, this can already be diagnostic if this was the only method you had to use and did not have anything else at your disposal. When you see these metallic flux inclusions, especially if it were to be attracted to a magnet, you can rest assured that you're looking at an HPHT diamond. However, when we view it in CPF, again, we see that extraordinary lack of strain. We still don't really see anything. And then we couple that with the first ORC, still don't see any notable strain. And the colors you're seeing is not a strain pattern. I'm not quite sure what that's attributed to. I do think that that is just the first order red compensator that's introducing color. So that's not anything I think that has to do with the strain pattern within the HPHT diamond. And then when we subject this diamond to 365 long wave UV, of course, we don't really see a reaction. This image was taken, I think I did a 10-second exposure on this, and still no fluorescence reaction. And I think it's important to note here too, that with my photomicrography, if I haven't stated, if some of you have seen in my posts, when I post-process my images, I do not do anything in the way of improving color. I only sharpen the image, white balance it, and reduce the digital noise, or maybe increase the exposure a little bit, but I do not do anything in the way of tampering with the color. So the point with photomicrography in general, of course, is to take images that you would otherwise see in the microscope. And so when you post-process it, shouldn't be far off from the exact thing you would see in the microscope. We then move on to a CVD grown round brilliant cuts near colorless. Using diffused light, we don't see anything. We don't see any internal graining. We don't see any zoning. We don't see any inclusions. But then when we use CPF, of course, this is when we can see the typical columnar or parallel growth pattern that some of you might be familiar with. And I've heard some individuals say that this is an absolute sign that this diamond is not treated. However, I do want to point out that this is only a strong indication that the CVD grown diamond is not treated, as observed by Dusan Simic. And this is also in his book with Branko. So again, invest in that book and certainly read up on that, because there's nuanced information in there. And of course, going back to my main point, that you don't want to jump the gun and just conclude without optical spectroscopy. Even though it's not necessary, I did use a first order red compensator. You can already see the strain pattern well enough. With a 1 ORC, you can see it a little bit more clearly, but it's not necessary. However, nobody's really, again, going to deny the beautiful natural aesthetic that you can see when combining CPF with the 1 ORC. When we move on then to another CVD grown round brilliant cut near colorless, this has been treated to improve color. This time, even though we still don't see any kind of zoning or internal graining, we do see the similar needle-like dense cluster of inclusions that I had shown you in a photomicrograph I had taken earlier on in my presentation. Again, if we were only using inclusion identification and diffused light, you could still find yourself in hot water by misidentifying the stone. But when we subject this diamond to CPF, we then find that we're looking at a fine crosshatch of dislocations. And this is interesting to note because in my opinion, in my observation, this is coming across as a modified columnar pattern resultant from possible HPHT or APHT treatment. As with my previous slide, it's not necessary to use a 1 ORC, but I've had a couple of my friends that have made mention that when they see this image, it to them resembles the aurora borealis and trees in the background. So take that at face value or for what you will, but again, the natural beauty of combining these two. When we move on to a natural round brilliant cut near colorless that is not treated, in diffused light, we don't see any internal graining or zoning, but what we do see is going to be one, not two, one needle or very small crystal inclusion. The reason why it's not two is because this is a lower half facet junction, and if you're not careful, you can confuse reflections or prism images to think that there are more inclusions than there actually are. So this is just a prism image of the needle or very small crystal inclusion. When we subject this diamond to CPF, we see a weaker uneven appearance that we could expect to see in a natural type 1A, AB natural diamonds. It's only a strong indication of being Cape series. For those who are not familiar with what it means to be a Cape series diamond, this is the term Cape. It's kind of an old school term, along with I think what is a river crystal, Wesselton. Just fun terms that are now outdated, but Cape referring to KLM and N in our current D to Z scale. And then when we subject this with CPF and 10RC, of course, nothing really changes, nothing's really exaggerated. But I do want to point out that with this crystal inclusion, we can also see, in addition to an uneven distribution of possible point defects, we can also see elastic deformation localized around this crystal inclusion. Just something interesting to note there. When we have another natural round brilliant cut, now we have a light brown, so we're lower on the D to Z, and it is not treated. Using diffused light, the first thing that you're going to notice are going to be the elongated tubular inclusions. And I've superimposed lines here, much like in a photomicrograph I've taken of a different natural diamond earlier on, where if you didn't already, you can vaguely make out some internal graining that's outlining the octahedral plane. And so I thought, for those who can't quite make it out, to go ahead and superimpose lines there. And that when we use only CPF, now we see the high order interference colors. So in my previous examples of using CPF with natural diamonds, all we were seeing were low order interference colors, but now we're seeing high order interference colors without the aid of a first ORC. And so we can see that we associated with the elongated crystal inclusions are interference colors that are now, of course, outlining the octahedral plane, as I had made mention here. And again, to reemphasize the points, when a natural diamond goes through enough strain, either during or after its growth, it's going to have greater variances in refractive index. And the greater variances in refractive index is what's going to cause you to observe a greater number of colors. One of my interesting points that I love to emphasize is that in my findings, I have not come across a strain pattern in lab-grown diamond that outlines the octahedral plane, like we observe a natural diamond like this one in the form of internal graining. Again, if anybody has come across an example like that, or there is literature out there that perhaps I have not discovered, please make me aware of this. But I think this is an interesting point to make because, again, in either HPHT or CVD, I have not seen, even just in diffused light, internal graining. So I do think that is a telltale sign or an indicator, again, not to be conclusive necessarily, just that you have a strong indication. In my next example, we have a natural round brilliant cut near colorless, not treated. This time I've included a crown view. So in the pavilion view, we can see, or just over here, a vaguer or hard to see internal graining. And again, this is something that you just need to see enough natural diamonds to go ahead and develop a keen eye for looking at internal graining. When we look at it in the crown view in diffused light, we can then start to notice some inclusions, maybe some clouds. And in fact, that this diamond was graded as an SI1 based on clouds throughout. When we subject the stone to CPF and first order red compensator, now we could feel confident that what we were seeing in diffused light is an extension of strain following the octahedral plane. Again, it's not entirely necessary to use a first order red compensator. We can see very clearly enough with the low order interference colors that we have something like perhaps a combination of extended and point defects. But again, always going to emphasize the point, it's always fun to use a 10RC. When we use long wave UV this time, we don't see that typical or more common color that natural diamonds can fluoresce, and then we see green. I'm not going to dive into detail as to why it's green, but if you didn't use diffuse light or CPF and you only used UV and you're not familiar or experienced enough in knowing that natural diamonds can fluoresce in colors other than blue, you might misidentify the stone. So again, just going back to the point that you want to use multiple methods when you are evaluating diamonds. This is an example I've been pretty eager to get to. This is one of my earlier findings when I first started out a few years ago. A natural round brilliant cut, near colorless. It's not treated for color, but it is treated for clarity. Aside from the horrendous out of round shape that we can see in this natural round diamond, we do see some inclusions that are in a dense cluster, more or less, here in the table. And that when we flip it over and look in the pavilion view, we actually can see two laser drill holes. And the point of contact to the table being right here is what we call as mirror touching, or at least when I was a diamond grader for the GIA, that's what we would call it, mirror touching. So we have two laser drill holes. And you can feel confident that when you see anything like laser drill holes or internal laser drilling, you can feel pretty confident you're not looking at a lab grown. And that's simply because most of the time, or the majority of the time, we can have a near full control of the growth process for CVD and HPHT. So if that's true, then of course, as everyone's already familiar with, our lab-grown diamonds can be higher clarity. Well, if they're higher clarity, then we won't need clarity enhancements unless there is a lab-grown diamond with a feather that has been fracture filled. Although I have not come across anything in literature or otherwise where I've seen a lab-grown diamond with a feather with fracture fill. So again, if you see clarity enhancement, you can feel pretty confident that you are looking at a natural diamond, not a lab-grown diamond. When we subject this diamond to long-wave UV, we get a very curious fluorescence pattern. So while the remaining body of the diamond fluoresces the common blue that we are familiar with, we're seeing around this dense cluster more of a yellowish fluorescence. And I did not send this diamond out for testing, so we're purely left to speculation at this point. I thought initially perhaps that maybe it was just the stress that the laser drill holes put on the surrounding crystal lattice. But I think it has more actually to do with the inclusions that are already present that have already affected the crystal lattice. But again, without advanced testing, we can't be too certain. Moving on to a CVD grown pair brilliant cuts, G color. This diamond is treated to improve color using diffused lights. Again, just like the other CVD photomicrographs that I had shared with you, we don't see anything in the way of inclusions, at least in this example, or anything in the way of internal graining or zoning. When we use CPF and a first order red compensator, now we can see something very interesting going on. This is going to be very different than the tatami crosshatch effect or the columnar pattern that we had seen earlier on in my presentation. And this, I do want to point out, bears a very close resemblance to what we can see in some natural diamonds. And in my next slide, I'm going to be diving into that in more detail. When we subject this stone to long wave UV, we see yet again another very interesting fluorescence reaction. And again, if you weren't to use any other standard method of evaluation and only use UV, this should raise a red flag. If you are experienced enough or know that natural diamonds don't just fluoresce in blue, they can fluoresce in green and perhaps a few other colors. I'm not too well versed in fluorescence colors, but the point I want to make here is that this should raise a red flag. And perhaps I should have said this sooner, but when using standard methods of evaluation, we're not being conclusive. The point is to simply raise red flags, it's simply to be suspicious. And this was an ideology that had developed in the diamond grading lab when I was with the GIA, with lab-grown diamonds oversaturating the market and entering the market in greater quantities. We don't want to be conclusive in our visual observations, just that we want to identify clues so as to be suspicious and then send it off for advanced testing. So as promised, I was going to round back to high order interference colors and that seemingly random pattern that seems to repeat itself throughout the stone. Here on the left, we have a natural diamond, the one that I had presented earlier in my presentation. This is only using CPF. This is not using a first order red compensator. So again, this natural diamond has gone through enough of its own problems during and potentially after its growth. But then when we juxtapose that with a CVD lab grown diamond that has been treated, the one in my previous slide, this requires a first order red compensator to then introduce the appearance of high order interference colors. And so the point that I wanted to make here is that I have not seen in lab grown diamonds high order interference colors in this kind of pattern that repeats itself. So I did think that this was an important finding in the diamonds that I've seen and photographed and documented so far. Again, just to repeat that, I have not seen high order interference colors that repeat themselves in an uneven fashion in a lab grown diamond, like without the aid of a first order red compensator like I have in a natural diamond. So there's something to bear in mind there. My last example here is a natural round brilliant cut yellow, and it has been treated to improve color. In the pavilion view, we don't see much of anything. We do see an inclusion, this feather inclusion hugging the girdle here. And the crown view, I'm sure the majority of you that have seen diamonds like this with this kind of neon color, I call it Mountain Dew, just because it's a kind of a fun reaction just alone to just diffused or transmitted lights. This should already raise a red flag with you. There's this kind of neon look to it. And so then you think, okay, well, let's go ahead and use CPF and first order red compensator. Doesn't really tell us anything other than we have indications of a natural diamond here, even using a first order red compensator. This isn't a pattern that we would typically see, again, in accordance to current literature and research that I've come across in lab grown diamonds. But that when we use long wave UV, again, we get an interesting reaction going on. And so aside from the blue fluorescence central to the body, we see hugging the girdle of this diamond a yellowish green fluorescence. This already, if you weren't already being suspicious of this diamond being treated, now you should be really suspicious and send this diamond off for treatment, because this is something that perhaps we don't see very often in natural diamonds. And in fact, to touch base on advanced testing, I included this FTIR Spectra data courtesy of Dusan Simic, not to scare anybody off, just to say that I did send this off, and this was confirmed to be treated, irradiated, and then heated to improve color. And that the greenish fluorescence we're seeing here is an indication of the penetration of irradiation before it was heated. And again, I wanted to include this because understanding how advanced techniques test diamond is important, because it examines the crystal lattice for defects and concludes diamond type and treatment for color. And so for those who are interested in wanting to learn more about optical spectroscopy and advanced testing, that's, again, the only reason why I wanted to include this slide, so that I can, of course, encourage all of you to invest in Branko's newest book with contributing authors, a few of which I've named already. You could find it on his website, and I'm sure other websites as well. And again, I'm not encouraging anybody that you need to get a PhD or physics, a PhD in physics or chemistry necessarily. I'd love it if everyone could, myself included. But just important to note that if you are interested in learning beyond which you could visually observe using standard methods of evaluation, then this is a great book to dive into optical spectroscopy. As promised, I was going to touch base on DVIs because, again, this is a very important topic with many retailers, I think more so than any other sector of our industry. And I know wholesalers are interested as well, but it's becoming somewhat of a concern, at least from my vantage point on the retail side of our industry. Understanding defects in diamond helps you to understand how DVIs can test and screen for diamond, and this enables you to choose a DVI most appropriate for you. And I'm not going to go into the details just for the sake of time here, but I will reference three points here. You can visit each of these 3 points here to get a better understanding. I visited all three, and they all have great fundamentals in understanding diamond verification instruments, what they do, certainly what they don't do, some misconceptions, and certainly do your own research before you go just simply buying one, because I've certainly worked with individuals who just simply buy one and expect it to do all the work for them, which leads me to my main point in this slide. Do not rely too heavily on DVIs, as they should be treated as a complementary method in addition to other standard methods of evaluation. DVIs are not advanced testing. They do not work in lieu of optical spectroscopy. They still have plenty of their own problems. Not saying you shouldn't invest in one. You should, just that you should do your own research before buying one and treat it just like CPF or DF or UV. So we just kind of bring it all together. So for those who are more so on perhaps on the sales floor or who buy or behind the buy desk or whatever your position is in retail, you know, understand why this even matters to you. I think it goes without saying that the deeper your understanding of something, the greater your ability to engage in and communicate on that topic. So the more you understand diamond science, the more skilled you'll be in your methods of evaluation. My analogy for this is, and nobody here has heard of a point-counterpoint argument against reading. Reading is good for you. Nobody's going to detest that for the same reason that understanding diamond science on a deeper level beyond some of the basics that I scratched the surface on earlier in my presentation will help you. The majority of my friends, just as an informal poll that I've taken, the majority of my friends and colleagues do think that they would benefit greatly from having this kind of above average knowledge of diamond science. In my personal experience, when I did have a sales goal, it definitely improved my communication with the consumer, reduced confusion and increased confidence, whether it was at the point of sale or during a sales presentation involving diamond goods. So it doesn't look good if you can't answer a question, or if your client or patron doesn't see you perhaps as the expert. Some patrons don't mind if they don't see you as an expert, but it still, again, couldn't hurt if you have this knowledge readily available when you communicate to and sell to your consumers. This also gives you an opportunity to disabuse consumers of misinformation that they might read on the internet. And I think all of us are pretty aware, and I'm just going to be blunt, of all the trash floating around on the internet. You have to be careful and wade through all of this. I can't remember who had said it, but there's an interesting a quote out there. If you don't know jewelry, know your jeweler. I think some of you might have heard this quote. I think the same is absolutely true for gemology. If you don't know gemology or gemstones, know your gemologist. This is just, again, another way to help disabuse people of misinformation. And again, in doing so, if you can do so in a way that lets them down gently and doesn't offend them through methods of effective communication, then you'll be able to build a strong relationship with them, and you'll find that with regard to marketing and sales, perhaps, that you'll have repeating clients. For appraisers, this kind of above average knowledge can improve your ability to identify possible clues to origin and treatment in larger diamonds, especially in diamonds that don't have lab reports. I do want to make a point here that even if it does have a lab report, not all labs are without error. Labs can still make errors. And in fact, this has been shown with all major labs. All major labs can make mistakes or misinterpret data, perhaps. And so it's important to keep in mind that for appraisers specifically, you can have dissenting opinions. I'm not saying make dissenting opinions willy-nilly all the time, just that if you, in your standard methods of evaluation, you observe something that might make you feel like you disagree with a lab, then certainly make a narrative statement to that effect. It's no surprise that lab-grown diamonds are oversaturating the markets. This, again, no surprise, everyone should know this. And it's because of this that clients are growing more curious and trust their jewelers to educate them, especially younger generations. And so we have, and I've been experiencing this quite a lot in recent years, younger generations are trying to educate themselves before even entering into your store. And so again, it helps to have this knowledge readily available so that you can answer questions, especially for the younger generations. For the older generations, not to try to pick on you, lab-grown diamonds are not fake. This is a common thing I hear all the time. Lab-grown diamonds are not fake. The fake is a term that we quite frequently use for simulants or clear stone to try to imitate diamond. The lab-grown diamonds, for the most part, are effectively the same as their natural counterparts, physically, chemically, and optically. It's a sad point to make, but I think it's an important one. The majority of consumers could care less about diamond science, but this still doesn't mean that you should shy away from gaining a deeper understanding of diamond science. And so I just wanted to make that point very clear. It's a tradition in all the talks I've given since I've been an undergraduate just to provide a joke relative to the topic at hand. This disregards destructive versus non-destructive testing methods. A gemologist can tell you with relative certainty what a gemstone is, while a geologist can tell you with absolute certainty what it used to be. Of course, as gemologists, we can't just grind up somebody's emerald into a fine powder, compress it into a disc, and toss it into an XRF spectrometer to understand its chemical makeup. So I just thought it was kind of a fun jest to make there. So as my last point, having a deeper understanding of diamond science, coupled with an understanding of how to use standard methods of evaluation, will improve your career, because I certainly know it improved mine. But special thanks to Branko for even making this possible. He's been a huge champion and encourager of mine. Also alongside him, Dusan Simic. Without either of these two individuals, who I'm very proud to call friends of mine, I would not be where I am. Nathan Renfro, John Koivula, and Billy Hughes, they've been largely responsible for my development in practicing photomicrography. So for those individuals, thank you very much. My entire AGS community and NAJA colleagues for their full support. They've been, again, amazing champions of mine. Robert James of the International School of Gemology, he always is kind enough to take the time to comment on my posts on social media, so I appreciate him. And lastly, Dr. Michael Wolf. He's an experimental igneous petrologist and the chairman of sciences at Augustana College in Rock Island, Illinois. He was my advisor when I was an undergraduate and remains to be a very close friend of mine. And to just the geology department in general at Augustana College, it's the very foundation for the reason why I have the passion that I do about this topic. And for those who are interested, this banner that I've had at the very top of all of my slides, aside from diamonds, I do have a knack for photographing thin sections of rock. So this is a photomicrograph that's been cropped of a petrographic thin section of a garnet mica schist. It's a metamorphic rock for more of the geology nerds who have been attending. Thank you.
Thank you, Randy, for a wonderful talk. I enjoyed it. I'm sure participants did as well. If you can just stop sharing for a second your screen, we can look at the questions. And I really appreciate that you, as a first American, has a clear language to transfer diamond science in more simple terms. I know it's not always simple. You have to keep a certain terminology, but I think you help people understand more diamond science, what's sometimes not easy for me or Dusan and other people who are English is not native language. So we have a few questions, and thank you for keeping within 1 hour. You must be practicing a lot. It was great. Exactly. So we have two questions that I'll read together because they're related to instruments. One from Antoinette Metlens. She was a great supporter. It is still of our conferences. She comes last 4 conferences: Italy, Montenegro, Cyprus, and Greece. She's asking, you showed a CVD under long UV light, but not under short UV. Do you have an image under short UV, and what will be? And in similar direction, question from our colleague, friend Dusan Simic. What method of instrument you see and you will buy as your next step in identification process?
Well, so thank you, Antoinette. She's been an amazing supporter of mine as well, and I'm very grateful to have spoken with her on a number of occasions. She actually is the reason why I even reached out to Branko to begin with. I'd originally spoken with her, and she said, you have to talk to Branko. You're just going to love him. So it's part of the reason why I even got in touch with Branko. But to answer the shortwave question, I do apologize. In the beginning of my presentation, I made mention that some of my images will be without fluorescence, notably shortwave. This is because either my torch has been out of commission, my shortwave torch, or in my earlier research and findings, I did not use UV. Of course, this is not a habit you want to develop. You want to, again, use diffuse light, UV, both in long and shortwave, and of course CPF and 1ORC. So I do apologize about that, but going forward, you can rest assured that my findings will include shortwave.
Great. Yes, I do encourage you as well to use more fluorescence. This is my big technique. Yes. Dusan is big on CPF and fluorescence, and I'm big on fluorescence. And I'm using CPF as well because this is first two line of defense when you look at the diamond.
Yes.
Fluorescence, CPF, of course, magnification is normal to use, looper microscope. Lydia Lee says,
I think Dusan had to answer his question. I'm sorry, I don't mean to cut you off, Branko. I spoke with Dusan several weeks ago. Actually, I sent him a text and I said, "How much is an FTIR spectrometer?" Because I have a very large interest in wanting to have my very own FTIR spectrometer. If it weren't for finances, obviously I'd be making payments on it for the rest of my life, I'm sure. But to answer his question, I think it would be an FTIR spectrometer.
Yes, I mean, in that direction, I can ask you my question. What is your next plan for next year? I mean, beside getting some UV light or different standard instruments, some of your photos are great, fantastic. I mean, I hope you will publish them in some publication or do something. Can you tell us more about your plans for next year or what you're doing? I know you're talking a lot to Dusan and myself, but what is your personal goals for next year? Yeah,
my goal has stayed relatively stable. The same questions that have been asked. I really just want to contribute the best that I can to the industry because it's very important when it comes to this topic, not just for the identification of natural versus lab grown, but also just for the protection of consumers, especially when it comes to appraising jewelry goods with diamonds. So I know Wade Abel at the AGS, he invited me to pair up with him and contribute to the AGS Spectra. I think it was in the last issue or 2 issues ago using CPF. So in any capacity I can to try to contribute my findings, I'm more than happy to. And I guess is actually also a very good point that I want to make is that for those who have made the time to comment on my social media posts, I very much so appreciate it. Even for those who are in a disagreeing standpoint, this is very important because from a scientific perspective, all scientists ever try to do is to prove one another wrong. So it's very important that we talk to each other and provide our thoughts. So I appreciate you guys on that. But yeah, just to contribute the best I can. I hope to publish. I don't exactly know how to go about doing that, but we'll see.
Okay, great. Great. I hope you will because they're very useful and in the future I'll plan more education. So maybe you can borrow me some of your photos, of course, with full credit to educate further basic level gemology. Anyway, there's a questions on fluorescence from Roman. If you can answer, if you cannot, we can. I can help you or other people. Why do lab-grown diamonds fluoresce stronger under short UV light? Can producer lab-grown diamonds make them fluoresce stronger under long UV light to confuse gemologist consumers? The same person asked also where I can get first order or CR could be bought.
Okay. The filter. Yeah, so unfortunately, I won't have too much insight into the first question. I am going to defer to the authorities on the matter of that, just Branko or Dusan. But with regard to the second question, Nathan Renfro had encouraged me to go to Edmund Optics. That's where I've bought my analyzers and polarizers and my, I believe it's a 550 nanometer first order red compensator. On their website, I think they have it as a lambda film, retardation film, lambda film, but it should be the 550 nanometer. You can get it in 3x3 or 2x2 inches.
Okay. I mean, I can just quickly put some light on fluorescence. It's different between HPHT grown and CVD grown, as you know, as you observe probably, but you will observe more when you use more short UV light. Is that HPHT grown fluoresce, obviously, not all of them, but majority of them, especially important melee diamonds, medium green, blue or blue-green, due to boron impurities during the growth of the HPHT grown diamond. So boron caused this fluorescence and phosphorescence. CVD grown is much more complicated, and this is changing. This is what I show one slide on this magazine article in magazine, Italian magazine, Gemological Review, that now what I see from new producers, especially US, CVD fluorescence is almost the same, long UV, short UV, maybe very weak or weak green or yellow, and not as big difference. Still, in older production, I see short UV slightly stronger, but you really have to use good photography, not enough just to use eyes. That's why it's very important what you're doing to make a photos of fluorescence, and I'm doing the same, and see the slight differences, and combine these two techniques together, and sometimes finish with what I'm doing always with the EXA or other instruments that use photoluminescence quick Spectra. So answer is unfortunately not easy, but it is complicated. I'm not gonna say use fluorescence only. And this is the reason why many DVI instruments based on fluorescence are giving misleading results or referring too much. They're saying 1, 2, 3, 4%, but sometimes the reality is 5, 10% referring. So I got even email from this week from a laboratory in Kuwait that very expensive instrument, $10,000, I won't mention which one, giving some indication that is synthetic and comes with the report of GIA that is a natural, big, important, flawless, big color diamond. I assume it is a type 2 diamond because many of them, when they come to these fancy shapes and they're high clarity in color are type 2A. So that's why a lot of this instrument giving a referral on type 2A. That's why I agree with you, it's not good to use the diamond verification instruments only. It's good backup. It has to be, I really like your conclusion that you recommend to combine with the standard instrument. This is very good. Okay, another question. Can you see strain in lab grown in polariscope as you can see with natural diamonds? I guess Lori didn't listen very carefully, but yes, you can see strain, but different strain, correct? Most of the time.
Yeah, and it's a part of that too is going to depend on magnification. The polariscope that I have, I know there are probably just a bunch of different manufacturers that make polariscopes, but the polariscope I have is from the GIA. There is a small magnifier on it. I think it's only maybe 10 by magnification. At that point, I would strongly recommend using magnification when viewing CPF. Of course, I know Branko has a portable a CPF instrument that you can use. Yeah. I just find it helpful to use higher magnification because CPF is a very nuanced method, and it does take a lot of time and patience and a lot of samples. So I think magnification is a very important variable in that equation.
Yes. So basically what I do, and probably I put this under microscope and then become very powerful tool to look at the cross-porous filters. Also, I notice maybe over 30 points, 40 point diamond, you can use a classic polariscope and maybe loop over it. But if it's a small diamond, you need the magnification for sure. And can you please repeat the difference between plastic and elastic deformation? Liz is asking.
Yeah, absolutely. So elastic deformation is going to be more of a localized strain on the crystal lattice around inclusions typically. The plastic deformation is going to be something akin to like pink argyle mines from Australia. Those diamonds, I feel bad for those diamonds because they had a very stressful history during and after growth. And quite often you'll see callable pink internal graining, as we call it. I'm sure plenty of you have seen GIA reports that might have a comment that says callable internal graining is not shown or something to that effect. But plastic deformation is going to be resultant from geologic forces, a mechanical stress on the crystal lattice, as where elastic deformation is going to be localized around inclusions or certain features in a diamond.
Thank you. Another question by Lori. You mentioned that the labs can make mistakes. Do they carry any liability for misidentification via advanced instruments?
That's a great question. I would say from an appraiser standpoint, and when I found this out, I was a bit shocked. And this is why it's important to know that appraisers can still have dissenting opinions so long as they have narrative statements. From my understanding, I have not come across case studies where labs have been responsible through an appraisal report. That liability actually falls on the appraiser, which is kind of counterintuitive if you think about it, because appraisers don't have the same kind of advanced testing instruments that major labs do. So it seems a bit funny, but to my knowledge, no, I have not seen or come across situations like that. Maybe those who are more experienced can speak on that.
Yes, I mean, legally, I cannot answer this question, but I know major labs have these disclaimers, its opinion and something like that. But definitely, each lab at some point made a mistake of point of research or point of testing. Because they're usually 1-2 years behind people who are doing treatments of growing diamonds, usually, but sometimes they can be closer. Okay, you mentioned greater variance in RI.
Actually, I have a kind of a lasting point. I apologize. I would probably say you can feel pretty confident to have a dissenting opinion if you're an appraiser and you're grading a diamond with a lab report that states it's lab grown, but you see surface graining or an indented natural, something that they might have missed. I would feel pretty confident. Go ahead and put that dissenting opinion in there, because again, that liability is going to fall back on you. Or if you have a diamond that clearly is attracted to a magnet and it has metallic flux inclusions, but the report says natural, have that dissenting opinion. That's a very important thing to go ahead and do. So again, don't be willy-nilly with it, but in those instances, there's very clear instances, you can be confident.
I can just add that it's very, very dangerous to buy diamonds or sell diamonds just based on reports only, and this is happening all the time. People doesn't see the diamond at all, and I've seen cases that people come with important diamonds to me just to verify if this is the same diamond, because Antoinette mentioned in her comment that very often, not very often, it's possible to counterfeit and alter the reports in circulation. Dušan Simic, at my as my speaker at a conference in Spain 2016, was just talking about this, how labs could issue report, and people who are making growing diamonds, or even easier, could cut diamond to fit the measurements with a completely different, similar color, but completely different origin, either HPHT treated or lab grown. So it's very important to verify important diamond with a qualified gemologist or lab or appraiser. Okay, another question. A lot of questions. This is good. You really steer some opinions here, and people have a lot of questions. That's good. You mentioned a greater variance in ARI, refractive index. Are you referring to the ranges that would be stated in a lab manual? She is referring to variance in ARI. I think you're talking about strain. That greater the ARI, the greater the difference in strain. I don't know what else you can tell.
I would say that so yeah, and that's actually kind of a good point for those maybe starting out or who might not be experienced enough. The variances in refractive index is perhaps not going to cause you to see a different value in the refractometer. It's OTL anyway over the limit, so you won't see the limit in the refractometer anyway. I don't know, depending on the severity of refractive index, if it's enough to cause perhaps something like a higher and a low RI, like we would see in tourmaline, for example, with a high birefringence. That's very observable. I don't know that we would see much of a variance. That's why I made it a point to say it's slight enough, but it's slight enough to still have a very strong impact on the crystal lattice. And I don't think it would be strong enough to perhaps see a great difference in numerical value, because under magnification using transmitted or diffused light, oftentimes we still don't see outside of internal graining. So I don't think we would see much, no.
Okay. Another question from Laurie. With the continuing advancement in lab-grown production with regard to less inclusions, is it the red flag to be prompted to test going to be seeing a relatively clean stone?
That's a great question. I apologize, I mispronounced her name. Cheatham Lule, who's with the Gem World International out near Chicago. She actually presented a great quote to me, and it's less difficult to determine that a stone has been treated than it is to determine it is unenhanced. This is another way of saying that high clarity stones are a bugger to try to evaluate. And so if you have a high clarity stone, yeah, you can be suspicious. That wouldn't be my first go-to, however, but higher clarity stones can be a bit tricky. For something like that, I would strongly just bear in mind exhausting all methods of standard evaluation that you have at your disposal.
Okay, then I can tell you one thing. The name of the new distributor of laboratory grown diamonds from Vancouver area, from Canada, is called Clarity Diamonds. What you would think when somebody offer you Clarity Diamonds? Clean diamonds, yeah? Yeah. But basically all these Clarity Diamonds are branded laboratory grown diamonds. They're all CVD. I've seen some huge crystals that 10, 12 carats. I was using them in a class with my wife Elena about crystals and rough diamonds, and showing difference. Of course, it's very easy when it's crystal. But yes, they're high clarity. But also I've seen 2 weeks ago over 15 karat D flawless diamond to verify, because it was not stated by GA what type it is. And I did a typing, type 2A, and it was a natural diamond by all characteristics, even if it was clean. But in this case, even advanced instruments give you indication, but you have to use cross-fluorescence filters, very important. And so it's not, doesn't mean that is if it's clean, it's synthetic, but yes, most of them are clean. So 2 more questions, and then we can finish with questions, and then another comment, and then we are about done. Jane saying, any good techniques for mounted diamonds with prongs, for example? Do you find it difficult to see results? She means CPF, I think. Have you tried? What about bezel? And this is a limitation, of course, of technique.
Well, as an appraiser, the majority of the diamonds that I see are mounted, which is a bummer. So if we recall back to the standard round brilliant cut that was mounted in the 3-prong martini stud, that would relatively easy because it's only got 3 prongs. And so you got the majority of the pavilion that you can observe. But if you have a full bezel setting or a tube setting, it's super difficult. I find it very hard. But it also kind of depends on the proportions of the diamond too. If you have a tube setting or a bezel setting, for example, and the diamond is cut more shallow, that actually could enable you to achieve bright field still, but then it would still depend on the depth of the tube setting or the full bezel. So it really kind of depends, on the mounting limitations and also just the overall proportions of the diamond. I've seen plenty of loose, shallow cut marquees. I hate those because they're super difficult to try to find any kind of pattern. So shallow stones can be difficult, but they could help in situations where mountings are extremely limiting.
Okay, last comment from Dusan is that lab in your slide that you mentioned CVD treated, he thinks that stone is natural based on pattern. They should just buy good CPF and long UV fluorescence. If you know the lab, you can mention who they are. If you want to comment, you're welcome.
Yeah, so that was actually, so there was a slide where I had presented another CVD diamond with the tatami pattern. This actually is a very great discussion to have. It generated a lot of curiosity for those who might have seen on my social media posts on Facebook last week, where I had posted. It was from IGI, and the report had stated that it was CVD grown, and a comment something along the lines of possible post-growth treatment or multi-step post-growth treatment or something to that effect. If we look into, yes, that thank you, Branko, that book, Branko and Dušan's book, there is a portion in there in the CPF, I think it's page 145 or 141, where you will see in a middle image the typical parallel or columnar growth pattern, of course only being a strong indication that it's not treated, but all around you can still see some tatami or broad banding cross hatch. So that's again going to that point where even though a lab says it's CVD, again, it could be a natural treated type 2A or type 2B.
Okay, thank you. I mean, there is no replacement for knowledge and for education. As I mentioned in the beginning, the last 3-4 years during Corona time and before, I was very active, and with Dušan as well. We did 10 webinars, not only us, based on laboratory grown diamonds with, I think, 19 international speakers, experts. And all these are part of this, we call it Intermediate Diamond Academy, and another 4 lectures on color diamonds, myself, Dušan on treatments, Mikko Armstrong on advanced portable instruments, and myself on portable instruments. So all these are basically possible to download as an intermediate diamond program. Possible to buy a book, of course, $49.95 with the shipping, or get this as a certified program. So this is basically what we're offering. And what I'm very excited, and hopefully, Randy, you will find a way to be part of it, at least some of your slides. I realized with this webinar, it was hugely popular. I have to say, we have doubled the number of participants than usual when you do intermediate advanced level. So it's mean the more people who are retailers or gemologists without reading Alan Collins and Dr. Zaitsev, I wish the more of that, but at some point, so I will do more basic gem and diamond program starting March 2023. I'm very excited to introduce first time Dr. Laura Kiefert as one of the instructors. So on gemstones, of course. So this is intermediate, and some of you are here today at this webinar, took this program from 4 different continents. I very appreciate that you're part of it and you are learning, and we are part of this group, Advanced Diamond Academy, that we exchange information, and this is a good place to give opinions. And I'm very proud and very happy that I'm able to catch still active and living for us heroes of diamond science, Dr. Aaron Collins. Sorry, I didn't put doctor in him, but Branko, Miko, and John and Dusan are the only not doctors in this book. This is a book that cover advanced diamonds. It did dive into more into diamonds, and Randy tried, I think, succeed, not completely. It's not possible completely to dive into diamond science in 1 hour or half an hour he had. So I think he explained the best he can this difficult terminology and difficult defects. But those who wants to learn more, this is 8 lectures based on this book, live lectures. They're available as part of Advanced Diamond Academy. This is what we're doing. And those who wants to do practical, I want to encourage you, if you're coming to Tucson show, I will do half-day workshop on screening and laboratory grown diamonds on February 3rd at AGTA official program at Mojave Room, and Laura Kiefert will do on ruby, sapphires, and emeralds. Very exciting workshops. I'm happy to possible to sign up at the bottom under my website, under shop, under workshops. And this is what I'm doing in the beginning. And of course, I'm going now international. I realize even if I'm in Canada and lived in New York, North America, I need to reach people who are in other parts of the world. And I start to do now, I'm doing for 10 years workshops in Australia, but I'll do first conference with the NCJV, what is a values organization in Australia, to be around the first week of July. You're very welcome to sign up at the Tucson show. I will give flyers. We'll put on the website in January, hopefully. It's a great program with a visit to opal mines, and we'll get a great expert on pearls, color diamonds, hopefully jade, and gemstones. Of course, Dr. Laura Kiefert is doing workshop there. And those who want to plan really ahead, in not so far, in a year and a half from now, I'm doing first conference in Slovenia, which is a small country, but very beautiful, between Austria and Italy, and with the workshops in Italy, in Cavallese, with a field trip, hopefully Emerald Mine in Austria, and visiting Swarovski factory. Very exciting program, and I will have everything in Tucson show. So basically, this is what I have to say. Let's see if there are any more questions or any other final remarks, Randy, from you, and we can wrap up. I see 2 more questions actually for you. So one from Ardian, he is a very nice guy, came to conference in Greece from Albania, believe it or not. So I have people now from new countries coming. I want to ask you, Randy, have the diamond manufacturers managed to deceive the identification technology?
This is an awesome question, and this is an idea that I've flirted with for a while. So not necessarily related to diamonds, but if we think about treaters decades ago, like the treaters in Sri Lanka, who would just sit without a shirt in their shorts, and they would blow on a pipe into a flame to heat treat sapphire to lighten the blue color. Nowadays, treaters are getting PhDs in physics and chemistry, and this is scary, and this should be lighting a fire under everyone, because it's these individuals who are trying to go out of their way to possibly deceive advanced testing techniques and an optical spectroscopy, maybe create spectra data that is similar to a natural counterpart, but is actually lab grown. So my response to this is actually, this is great for standard methods of evaluation, especially CPF, because CPF is something they're not thinking about. And this is why I emphasize CPF, because you can lean on CPF quite a bit. Of course, obviously you want to use, again, multiple methods, but to my knowledge, I'm not too hopeful that they'll succeed 100%, but they're trying.
Very good, and thank you, Randy, for your time. And I think it's the best way to finish this nice 1.5 webinar that will be online hopefully next week. My webmaster David and me will work on this over the weekend with Randy. And so those who miss it, and the people in Australia, I'm sure many of them more sign up, but they couldn't listen 2 or 3 o'clock in the night. So we'll put for them, and also for YouTube channel BrankoGems. So what we can do, Randy, just continue to do our good work, and you as well. I'm very happy that you were inspired by Dušan's and my books, and you start to use these techniques. And we need young people like you. And I just realized that I'm 56, and most of the speakers were older than me in the last 3 years, only like Thomas Henschwagen, and you are younger, what is a good to see younger people, I mean, 30s coming to do research. And Clara said that this is a great finish. No question. I want to thank you and Randy for excellent presentation and for giving your time. Looking forward to hearing you both speak again. I think you might be coming to AGS Conclave. I'm not sure if it's happening or not 100%, but this is something we are waiting. And I can tell you, I will continue what I'm doing, sharing my knowledge and giving you a chance to hear great speakers like Randy from around the world. And you can see these two pictures, one from my latest workshop in Australia, 2019 on the left. This was my record, 40 people taking a class. And one from Cyprus, 2018. We have people all around me for 6 different countries coming to the workshop. And of course, to remind you, this is a Randy's photos of interesting fluorescence. And why it's fluorescent green? This is something we want to study more. And I'm sure, Randy, with the time and energy you're putting into this, you will have a chance to answer all your questions with advanced instruments working with the other people. Thank you a lot, everybody, for coming and for supporting this kind of education. Bye-bye.
Thank you.
Thank you.